So this is the NAND gate 4011. So we have this 5 volts for 14 5 volts ground, and then we use this NAND gate. So pin 1, 2, A, B, and then this output. Alright, we have this A, input A, B, and then output to the multimeter, voltmeter. Now as since this is 0, it means low voltage. So when it turn on, 5 volts, and start to increase, but we have to ground this input. And you see this is output. This is 0, 0, no input, so 0, NAND, 0, you have the output 5 volts. So this output 5 volts for the NAND gate. Alright, this basically is what you have verified. So the NAND gate, and then the symbol is this guy. So NAND gate consists of the AND and inverter. And what you have tested, we have the input A 0 voltage, and then you're going to have output 1. 1 is like 5 volts maximum. Alright, so we're going to test if we have the 5 volts input for input A. Right, so this is another input 5 volts. From here you get the input in 1, but no, it's 0 here. So NAND, which is 1, 0. You have 1, 0, and the output is also 5 volts. 1. And let's do the same if you have this input for B, but you have to ground this first, ground the input A. Alright, now it's ground, and then it's 0 and 1. You have 5 volts. This is we verified this 0, 1. You still have output 1. 1 is for 5 volts. Now we try to input A, input B with 5 volts. That means that we have to join this together. Alright, we have to join these input A and B. Look at that. Alright, and then we have input together. And what you have is that you input 5 volts to A, input A, and then input B, and then you get nothing. You get like 1 volts. Now 1 volt is below 5 volts, you consider it 0. So you have this output, fulfill this this table. Alright, this is the first section of the lab 16. Done. Okay, so this is section 3, lab 16, and you have to connect the input A and input B, alright, make it into this inverter, NAND gate inverter. So the instructions say that you need to have this pot, and then fit in this 5 volts to the resistor, and then the wiper is to the input of the NAND gate. Actually, it's NAND gate inverter. All right. Now here, this is what you have. All right. You have 0, 0, and then you should have the output 5 volts. Now, and then you measure this V in. What is V in? V in is now 0. And the instructions say you need to check, you have to vary this V in. This is what I have here, the pictures, the circuit diagram for the section 3. So you have this support, and then you wire this wiper. So first you start with here, start the wiper here, means you have this, the voltage drop is 0 for V in, is what we have here, close to 0. All right, and then you have to increase the V in until you see there is a change for the output. Now the output is 5 volts. The output is 5 volts, and you want to see this output 5 drop to 0. Then you measure this, what is the V in. All right, this is the limit for us to get this, the V in. All right, so we change. So at first we need to put this voltmeter to the V out. All right, and then we see this is 5 volts, and then we change the wiper, we change the V in. Change the V in until is dropped from 5 to 0, or the minimum voltage. So we keep changing. All right, we keep changing, and start to see. All right, you see the state change. It dropped from 5 to 0, and then you measure this. What is the V in? And then the V in, this is the lower limit, which is called the VL in this section. All right. Now you want to go to check the VH. That means you have to go all the way up, and you want to determine what is the VH to have this state change, to have this output change from 5 to 0. All right, we go all the way up to 5 volts for the V in. And then you start to see it's increasing to 5. This is maximum because we fit in 5 volts to the port. And now this wiper is on this side. All right, this wiper is now in this the maximum, and then the V in is now 5 volts. We have 5 volts for the V in. Now you go back, switch the voltmeter to V out from the inverter. Now you see this is 0. Why? Because you have this input 5 volts to A and B. All right, so you have plus, and then the output should be 0, which is the NAND gate. All right, now we turn the port, change the V in until this becomes 5 volts. So now it's constant. If you change this one, it's 0 volts. A bit hard. All right, and then you change the V in, and then until the VH, you're going to have this state change. All right, this is the one, 5 volts, and then you measure this. What is the maximum V in? This is 2.47. Right? I forgot the value just now. What's VL, what's VH? You probably can. You probably have to write this number in your report. All right. I didn't have any report written. You based on this number and then put in your report. Okay. So basically it's done for 4011. The next is that we have to repeat by using the 7400 NAND gate. So we're going to change to 7400. All right. We have the 7400. 7400. I need to make sure it's 7400. Okay. All right, replace this. Turn off the power. And then this. $7,400. All right, you're going to do the same. I'm going to go back to the maximum. Measure this. All right. Put that in output. Turn on power. Measure this. What is V in at the moment? I check the V in, so I'm going to go to the maximum. I'm going to turn to maximum 5 volts. All right, 5. All right. Now I switch this voltmeter to the output. And then I'm going to rotate the wiper so that the output of the NAND inverter gate is going to change state from 0 to 5. Okay, that is the voltage. Well, this is not 5, 2.6. And I'm going to measure this. All right, this is the number I have. So this is V in. Could be VL or VH, we do not know. So record the number. And then I'm going to do the other way around. I'm going to turn. All right. I'm going to put back this one and then have this 0, starting from 0. All right, so close to 0. This is close to 0. All right, switch it back. All right, it's supposed to have 5 volts. Now I have to turn to increase this V in so that this 5 drop. The 5 volts drop to 0. Okay, this dropped to 2.4, I think. And I'm going to check what's the V in that I have. So this is 1.9. And this, compared with this number, just now is 1.2, and this is 1.9. So 1.9 for V in. This is VH. This is VH for 7400. 1.2 is 1.2 volts VL for 7400. Okay, this is part B. We have these what I call the 3-state logic. So I have this one 7400 to 7400 NAND gates, right? And I also construct this 7403, right? 3-state logic gate. Now, this one here is 7400. So as you see, I think this 1, 2, 3 is the A, B, and then output. And then the other gate, and then gate is, this is C, D, and then output. And the output, you see that I have to connect them to the output. So this is plus to the voltmeter. And so far I have 5 volts. This means that I have to input A, B, C, D are all connected to ground. It means it's 0 volts. So 0, 0, in this case 0, 0, 0, you have output 5 volts, means high level, right? 2 AND gates is what you have. Now, the experiment I'm trying to do here is that, say this is the poor logic gate. Now, what it means by that? Now, you have to answer the question. All right, so I wish I can have extra hand here. Let's see, if I pull this out, that means it's going to drop to below 5 volts, all right? So it's going to have, let's say now I'm going to fit in 1, 1, 1, 1. This is what I want to verify. 1 for the input A, 1 for B, 1 for C, 1 for D. That means I have to fit in 5 volts. This is the 5 volts I have. So I'm going to fit in here. And then you see you have 0 output. And this is good, I think. But I think you have to, I think I'll give you this page number. I scan this out, and this is the good information for you to learn what it means. Like, what happens if you have this back to ground, and then pull out this A, all right, and look at that, you still have 5 volts, and then fit in this A with 5, all right, and then the rest still with ground. This means B, C, D are zeros. Then only A is 5 volts or 1. Now what you get, the output is 5 volts, all right? Okay, so this is the result that we have for the 7400. Okay, now I'm switch this to part B. Second part of the part B. So the output will be here. I'm going to then measure output, and then the ground. This is the ground. And again, this is 7403. So I have these A, B, and then output, and then C, D, and then you have output. Look at it. So output we are joined together, and then this be out that you're going to measure. Now you have 5 volts, and the input A, B, C, D are ground to 0. They ground to 0. All right, it's basically what you have here. 0, 0, 0, 0, and you have output at 5 volts. Now, I take out this one, and now I switch it. Now you can see this one doesn't give 0 as the one we have earlier. All right, and you should explain how. I think do some study on the text page 254, I think. So I think the 7403 doesn't work. Now the circuit has extra 1K ohms, all right, which is here, connected to 5 volts, and then to the output. This is what I have. All right, this is 5 volts. Now try this, put it back this A, B, C, D to ground, and then I have 5 volts back, and then pull this A out. Now I still have 5 volts. I fit in this A with 5 volts. You still have 5 volts there. All right. Okay, so you compare this 7403, 7403 with the 5, with the 1k ohms fit into the output, and then we have the earlier circuit, which is 7400. All right, and these are the part B.